Hello everyone, in this video we're going to be going over how to find additional coterminal angles in the unit circle, both in degrees and radians. Be a pretty short video, so let's get at it. Basically, what you got to remember about coterminal angles is that they are going to be additional rotations around the unit circle. So for instance, if you have a 60-degree angle and I want a coterminal angle that's clockwise or counterclockwise, I'm just going to add 360. So if I take 60 and I add 360, well, that's going to give me 420 degrees. And that's considered coterminal with 60 because they're on the same spot. Okay. And additionally, I could go in the other direction clockwise and I could subtract 360. And if I do that, I'm going to have negative 300 degrees. And that's considered coterminal as well with 60. So just getting coterminal and terminal angles, both positive and negative, is just a matter of adding or subtracting 360, depending on which direction you want to go. Now, if you're dealing with pi, you can do the same thing, but instead of adding or subtracting 360, you got to remember that this is going to be 2 pi radians. So 360 is 2 pi radians. So instead of doing 360 degrees, you do just, let's say if I have pi over 4, and I wanted to get in the positive direction again, I would add 2 pi. And I'd have to convert that. So, 2 pi would reduce to, well, I'd want to multiply by 4 over 4 to get the common denominators. And that's going to give me 8 pi. So it's really 1 pi plus 8 pi is going to be 9 pi over 4. So 9 pi over 4 would be considered the positive coterminal angle, where if I want to do pi over 4 and get a coterminal angle in the negative direction, I would subtract 2 pi. And so again, I would just get common denominators, and that's going to give me, again, 8 pi. So 8 pi, 1 pi minus 8 pi, and that's going to give you negative 7 pi over 4. So you can get those as degrees and then work your way back into radians. But the idea is that you have to have, if you start with a degree, you want to end with a degree. And if you start with a radian, you want to end with a radian. So let's get into a couple examples. Okay, so for getting coterminal angles, you got really an unlimited amount. It just says find one. So we don't have to get through a whole bunch. But the idea is you just want to basically take your degree and you want to add or subtract 360 times however many rotations you want to do. So let n stand for the number of rotations. All right, that's the basic formula. So you're either going to add 360 or multiples of 360, or you're going to subtract 360 or multiples of 360. So if I just want to go with one positive and one negative, I'm just going to do for the positive 225 plus 360. And then for the negative, I'm going to do 225 minus 360. And we'll just throw it into our calculator and see what we get. So 225 plus 360. Get your 585, and then you get 225 minus 360, and you get negative 135. And that's all there is to it, guys. So you got your 585, and you got your negative 135. Now, if you want to keep going, if you don't want to have to, if you're asked to get several coterminal angles, you could just here's a little calculator trick. If you have one of these TI-84s, you could just enter the number in and you can say plus 360 and it takes your previous answer. So if you just hit enter, and you can just get an unlimited amount of coterminal angles. You can do the same thing with subtracting. Okay, just enter your number in, minus 360, enter, and you have as many as you want until your heart's content. All right, let's try the next one with radians. So 2 pi over 3, we want to get a coterminal angle, both positive and negative for this. Pause the video, try it on your own. Okay, the setup is the same as last time. You want to add your full rotation for a positive. You want to subtract for your negative. Now I use 2 pi because 2 pi radians is equivalent to 360 degrees. So if I'm sticking with radians, I'm just going to keep it in radians. So we're going to want to get common denominators. And you can do that by, since this doesn't have a denominator, tack a 3 on the bottom. 2 times 3 is 6. So it's going to be 2 pi over 3 plus 6 pi over 3. And those are going to combine to 8 pi over 3. So it's going to be 8 pi over 3 radians, and that's equivalent to 2 pi over 3 radians in the unit circle. Same thing with the other one. We want to get a common denominator. So again, just tack a 3 there. That's going to be 6 pi again. So 2 pi minus 6 pi is going to be 2 pi over 3 minus 6 pi over 3. And that's going to be negative 4 pi over 3 radians. So that's how to do it without necessarily needing to convert it to degree. If you want to use your calculator and use degrees, this is, I mean, it's more work, but here's how you do it. If this is maybe a better route for you, go for it. So I'll just do it with my calculator. You can watch. So you would first convert 2 pi over 3 as a degree. So you got to multiply that by 180 divided by pi. And now you're at 120 degrees. And so at 120 degrees, if I want to get a positive one, I'm going to add 360. So plus 360. And that's 480. Now to get that as a radian in pi, I have to reduce it. So I have to divide by 180. So 480 divided by 180. It'll give me a decimal, 2.6 repeating. If you hit the math button and go enter, enter, that'll give you 8/3. So you say 8 pi over 3. Same thing with 2 pi over 3. You can, again, 2 pi divided by 3. We already know that's going to be 120 degrees. We already calculated that. So I do 120 minus 360. And then divided by 180. And then let's reduce that. Math, enter, enter. And that's going to give you negative 4/3, negative 4 pi over 3. If you are at a class that doesn't allow calculator use like this, then that's not going to really be an option for you. So you would want to stick with the method I wrote down. Well, guys, thank you for watching. That's all this video has to offer.